Now you are probably wondering what's in my hands right now. Now basically what I have here is a printed circuit board of an old mouse that I used to have. And as you can see, on both sides of the board we have the components that make this circuit function as a mouse for a computer. Now what interests us the most in this lesson is what makes these components stick together to that one single board. In fact, in this zoomed-in view, we can see that a type of metal was melted to connect each component to the board. Now, this type of metal which connects each component to the board is called solder. And the method of melting this solder to connect a component to a board or wires together is called soldering. As you can see, each tiny component and each lead of every IC is connected to this board by soldering. And the advantage of soldering is that each component is permanently joined to the board, so you won't have to worry about them falling anytime soon or get disconnected from the board. And here in this example we can see that soldering can also be used to connect two split wires together. Now let's take a look at what tools are used for soldering. Firstly, of course, we're going to take a look at the solder itself. Now solder is a metal alloy usually made up of a mixture of 60% tin and 40% lead. Usually, solder is provided in a wire form, and its low melting point makes it ideal for soldering. Next, we have the soldering iron, and this is used to heat up solder and make soft solder joints for components and wires. When plugged in, the soldering iron is going to start heating up. Therefore, we have to be careful to never handle the soldering iron from the heating element part. If you were ever to touch this heating element part, you will risk of getting burned. Therefore, you have to always be careful to handle the soldering iron from the safe handling part, as you can see here. Next, we have the soldering stand. A stand such as this one is used as a place where you can rest your hot soldering iron to prevent you from damaging any surfaces. A stand such as this one usually contains a sponge compartment where you could put a damp sponge used to clean the tip of your soldering iron when soldering. On our soldering stand, we also have helping hands. These are used to handle small components and our circuit board during soldering. Some soldering stands also contain a magnifying glass. This will be of great help when soldering very small components to your board. Next, we have the desoldering pump. This is used to remove any unwanted solder from a circuit. When solder is still in its molten state, you press the plunger down and then press the button for the air and solder to go up the desoldering pump. Next, we have the side cutter. This is used either to cut wires or cut the component leads. Next, we have the wire stripper. This tool is used to strip away any plastic casing of wires quicker and easier. Let's see the demonstration of how it works. Another tool used in electronics is the long nose pliers. This is used to handle small component leads or wires. The last tool that we're going to talk about is the multimeter. This is a device used in electronics to measure voltage, current, and resistance. And you could change what the multimeter measures by turning the dial in the middle. Now, in order to start measuring, probes have to be connected to the multimeter. The positive probe is going to connect it to this wire input, as in this example we're going to use the multimeter to measure resistance. So let's connect the two probes, remove their caps, and connect them to the wire inputs. The negative probe is always going to be connected to the common wire input. Now let's use this multimeter to measure the resistance of this resistor that we have here. By looking at the color bands, this resistor is supposed to be a 1000 ohm resistor. However, you could never be sure what resistance a resistor is going to give you in your circuit. So firstly, let's set our multimeter to measure resistance. And as you can see, there's a range of numbers and values that our multimeter can measure. I've set it to the 2K setting, as I am expecting a 1000 ohm reading. However, let's see what the multimeter reads. So let's connect the two probes to our resistor and see what value our multimeter shows on the display. And unfortunately, our 1000 ohm resistor turns out to be a 975 ohm resistor, so it's not accurate. Now, to hold our value on the display, we press the hold button. This is so the value wouldn't change all the time. Now, to remove it, we'll press hold again and then switch off our multimeter.